Pre-algebra, Mr. Lawrence here with your flipped lesson. It's on the Pythagorean theorem again. And remember, the most important part about the Pythagorean theorem is that C is the side across from the right angle. It's always across from the right angle. Now, a real low-level type of problem would be to say, all right, find the missing side of this right triangle. All right, I'll make this x, I'll make this 12, and I'll make this 24. Okay, I know the Pythagorean theorem is a squared plus b squared equals c squared. The most important part, I know I just said this, but many of you don't listen, is to get c identified. I go to my right angle and I draw a line across from the right angle, and there is c. All right, 24 is the value of c. That's the first number I'm going to put in my equation. I'm going to put 24 squared. Okay, now the a and b don't matter. I could call a x squared or ax and b 12, or I could call a 12 and bx. It doesn't matter. I'm going to go x squared plus 12 squared. All right, it doesn't matter. Now you might find it easier to solve this equation with the x term first. Fine, do it that way. But mathematically it'll come out the same. My next step is to square everything. X squared plus 144 equals 24 squared, and I want to say that's 496, but let me double check that. As I'm saying, it just doesn't sound right. 24 squared, 576. There we go. I'm glad I double checked myself. 496 just didn't sound like enough. All right, 576. Now I'm going to subtract 144 from each side. Omar can tell you that I'm going to subtract 144 because this 144 is positive, so I need to use subtraction to undo it. Use the inverse operation. All right, x squared is going to equal, looks like a 432. That's x squared. How do I undo squares? You will not say divide. Do not tell me to divide. Division undoes multiplication. All right, we don't undo squared numbers with division. No, we don't. We take the root, specifically in this case, the square root. If it had been a cubed problem, which we'll talk about cubed problems in probably a couple of weeks, but if it had been a cubed problem, we would take the cubed root. But it's a squared problem, so we'll take the square root. We get x on this side, and I will go ahead and go to my calculator and hold on one moment. Okay, I have to take the square root of 476. Let me clear this off, put it on large screen so you can see better. I take the square root of 476, and I get this big long decimal. Rounding to the nearest tenth is usually sufficient, so when I round this to the nearest tenth, I'm going to look at this 8 right here. This 8 will either remain an 8, or the 1 will cause it to change into a 9. One of those two things will happen. So I look at the number behind the 8, immediately behind. If it's a 5 or more, I raise the score, which means it goes up to a 9. If it's a 4 or less, I give it a rest, which means it doesn't go up. It stays 8. Give it a rest. I learned that from Stephen Brooks many years ago. Now, Marissa Hecker shared with me today during, I don't know, I think it was 6th period, maybe it was 4th, that one good way to remember which place it is, to put a little 1 here above the decimal point, and then to put a 0, because the 8 is in the tenths place. Put a 0 above the 1 is in the hundredths place. Can you see the 100? It's not 100, it's hundredths, because we're to the right of the decimal point. Then, of course, thousandths, 10,000ths, etc. So it looks like this answer around it is going to end up being 21 8/10. That is the rounded answer. So let me get that up here. X will be 21 8/10. All right, you should be pretty good at this. This shouldn't be totally brand new. Somewhat review. Now let's take a situation of, let's say we have a tree. Okay, and let me draw my beautiful tree. Ooh, it's such a beautiful tree. All right, and your kite is stuck at the top of the tree. Okay? And you know that you are 50 feet. Here you are. Oh my, you're looking lovely today. You're 50 feet from the base of the tree. You also know that you let out 75 feet of string, 75 feet of kite string. Okay? I want to know how tall the tree is. Well, can you see the right triangle? It's right there. All right. There's my right triangle. I'm looking for x because I don't know how tall the tree is. Okay, and obviously I'm only measuring to where the kite is stuck, but we said it's stuck at the very top. Well, I need my good friend, the Pythagorean theorem. It's got my back. All right. And I'm going to identify C first. When I go to identify C, I find my right angle and draw my line to it. The side I hit across from the right angle, that is C. So I'm going to stick 75 in for C. A and B don't matter. Most of you would rather solve x squared plus 50 squared, and so that's how I'm going to do it. But if you wrote 50 squared plus x squared, you're going to do the same exact steps. All right, so I'm going to bring my work down here. X squared plus 2,500. What did I do? I squared 50. 75 times 75, well, 7 times 8 is 56. So it's 5,625. Just a little trick I know for squaring numbers that end in 5, two-digit numbers that end in 5. To get x squared alone, Omar can tell you to go ahead and subtract 2,500. And we get x squared equal to 5213, 3,125. I'm not done. In fact, if I thought I was done, my answer wouldn't make any sense. Okay, how the heck could the tree be 3,125 feet tall when I only let out 75 feet of string to get my kite stuck at the top of it? It just doesn't make sense. To undo the square, x squared, I need to take the square root. Remember, we will not say divide. Oh, by the way, Rimara, I hope you're listening because I know your mom is. All right, so I'm going to take the square root of 3,125, clear that out of there. Second, square root 3,125. There we go. And it looks like the tree, if I round it to the nearest tenth, is approximately 55 and 9/10 feet tall. 55 and 9/10. So x is going to equal 55 and 9/10. Now, we could convert that and figure out how many inches it is. It's not 0.9 inches. It's not 9 inches because inches aren't based on 10. They're based on 12. So I know it's 55 feet. But how many inches is it? Well, I'll take the decimal part of my answer and I'll multiply it by 12. Why 12? Because there's 12 inches in a foot. This will give me the number of inches that 0.9 represents. 0.9 times 12 ends up being 10.8 inches, or 10 and 8/10 inches. So it's 55 feet and 10 and 8/10 inches. Okay, that's how tall the tree is. So if you needed a ladder to reach it, it would have to be minimal that tall. It actually have to be a little bit taller because that would be the shortest distance in a vertical line, and your ladder, to do it vertically, would have to be mounted to something on the ground or it'd fall over. You have to lean it against the tree, so it'd have to be a little bit taller, and for you to be able to climb up, it'd probably have to be a good couple feet taller. But the tree itself is 55 feet 10 inches tall. The whole trick is to draw a picture. We're going to do one more problem, and we're going to say that you were out boating one day and there was a dock. Ooh, now you're going to see my wonderful math skills. Excuse me, my wonderful art skills. Now you know why I teach math. All right, and there's the dock, and here's the big old river, right? Okay, and let me see here. Oh, got to put a little shark in the river. It's a freshwater shark. Do 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 do. All right, and your boat. Now, when you had set out from the for the trip, you knew, let me do the shore in here, make the shore green, okay, your boat you knew was being carried downstream by the river. All right, so you started off here, you went off from the dock, ah, shark, the river took you downstream. Right now you're down here, okay? Now you know that you are 20 feet from the river, from the edge of the river. You're in the river from the land, excuse me. And you also see a mark here, and at this mark there's a lighthouse. Let's see if I can draw a lighthouse. Ooh, look at my lovely lighthouse. There we go. Looks like a Green Lantern lighthouse. All right, there's my lighthouse. Okay, and you know that the lighthouse is 100 feet from the dock that you set out on. How far are you from the dock? Well, you're not 100 feet. That's the distance from the dock to the lighthouse. You're not 20 feet. That's the distance from the boat to the shore. You're an unknown amount of feet, right? See the right triangle? Because I have a right triangle, I'll redraw it over here without all the clutter and accoutrements. And I know that's x, and that's 20, and that's 100. I can set up a Pythagorean theorem to solve for the missing side of the right triangle. And in this case, my missing side is x. It's not always x, but in this case it is. So for a squared plus b squared equal to c squared, in this case I know that c is x. B doesn't matter if it's 20 or 100. I'll make b 100. I'll make a 20. And now I will square and get 400. I will square and get a 1 followed by 4 zeros, which looks like it's 10,000. That'll equal x squared. 10,400. All I did was add x squared. And now, how do I undo a square stash? That's right, stash. I take the square root of each side. So x is going to equal, I need to take the square root of 10,400. All right, it looks like rounding to the nearest tenth is going to be 101. Oh, wait a minute. This 9 here is either going to change into a 10 or it's going to stay a 9. I look back at the 8. It tells me to add 1. That's going to become a 0. This is going to turn to a 2. And it looks like, rounded to the nearest tenth, I'm actually going to be 102 feet from the dock. Okay, feet. All right, that's the Pythagorean theorem. We'll get some more practice with that tomorrow. Mr. Lawrence signing off.